Welcome to my channel, and today we will discuss the problem which we have given in our Facebook page, and that is we have taken the two complex. Okay, so one is a cis carbonyl, and another is a trans carbonyl. Okay, so here the problem was what is the number of signals in IR and how are the intensities varying. Okay, so before discussing that, we have to know there are two types of stretching frequencies which mainly contributes to the CO vibrations and are out of the fingerprint region. Okay, so these are the two stretching frequencies. One is the antisymmetric stretch and another is the symmetric stretch. So in both cases, the cis one and the trans one, the two type of stretch are possible. Okay, so in case of cis, we can see like in the antisymmetric stretch, one CO will expand here and another CO will contract. Okay, so and these are the other ligands. And for the cis one, and for the symmetric stretch, one CO will expand and another CO will also expand. Okay, so this is the symmetric stretch. Okay, for this is one, and similarly for the trans one, the antisymmetric stretch, we can see like one will expand but the other will contract. Okay, and for this for the symmetric stretch, one CO will expand and simultaneously another CO also expand. So for these two type of vibration, we will get two IR signals for both the cis and trans complex. Okay, so now what about the energies and the intensities? Okay, so we see for the, let's suppose this is the trans one and this is the trans one. Okay, so for the the symmetric stretch, for this we have to expand both of the CO. Okay, so this needs more energy, right? Because we are expanding both of the CO, and that's why if we get a spectrum of IR which is transmittance versus the new birth and in centimeter inverse, here we can easily see that the symmetric stretch will come in higher in energy. This is the higher in energy, this is the lower in energy, like lower new birth, this is the higher new birth, and this is the symmetric stretch, and the antisymmetric stretch will come here for the trans case. So now, as I have already shown, the symmetric stretch has lower frequency compared to the antisymmetric stretch. It is because, like for the symmetric stretch, the CO dipoles are oriented opposite to each other, right? So they kind of cancel each other. But it doesn't mean that the dipoles are definitely zero, because there are other kind of vibration like bending, scissoring, etc., that are also coupled up with that of the stretching vibration, and this makes the dipoles a little bit non-zero value, and that's why we get a small intensity here. Okay, for this symmetric stretch, and that's why the symmetric stretch had kind of lower intensity. But what about the antisymmetric stretch? Why it has the higher frequency in case of trans? So we can see that dipoles are kind of favoring each other, right? So they are directed towards each other, and that's why they have got a lot d mu dr value, which directly is related to the intensity. So this value is very high, and that's why we get antisymmetric stretch have higher intensity. Okay, but what about this cis one? So we can see for both the symmetric and antisymmetric stretch, they have kind of higher dipole values, because in both the cases they do not cancel each other, right? So that's why for the cis one, they will have this kind of, the intensity will be much more similar. Okay, intensity will be much more similar, and that's the case here. In case of this carbonyl, metal carbonyl, which has two carbonyls, so they will have like a similar intensity in both the cases, like the symmetric stretch and antisymmetric stretch. But in case of trans one, they also have two signals for the symmetric and antisymmetric, but the symmetric stretch will have a lower intensity compared to the antisymmetric stretch. So this is the answer to the problem, and also the concept behind that particular problem. And if you find this video useful and like you have learned something new, then please subscribe and share this channel. This helps me a lot to make future videos. Thank you.